Last class, we talked about solving linear systems using graphs and substitution. Today, we're going to use elimination. Elimination is a strategy that employs the addition property of equality, where if I'm adding equivalent values to both sides, so this looks in the form of an equation. So if I'm adding one side of the equation and the other side of the equation at the same time, I'm keeping the balance, even though I'm not, like, say, adding 2 to both sides. I might be adding some algebraic expression that I know is equivalent to 2 on the other side. And so elimination happens when I have a pair of additive inverses. So for example, if you have x plus negative x, those two add to 0, and so that eliminates that value for x. We'll talk about equivalent systems, which are systems that have the same solutions. Okay, so, oops, scroll too far. So for the first example, it's asking us to find the y value. So our answer is not going to be an ordered pair. Our answer is just the y. So I want to be able to add these two equations together and try to eliminate a variable. So if I have 4x minus 2y equals 7, and then x plus 2y equals 3, notice that by simply adding them together, I actually eliminate y. So 4x plus 1x is 5x. Negative 2y plus 2y is that additive inverse, so that equals 0. And then 7 plus 3 is equal to 10. So now I have one equation that is only in one variable. So I can solve for that variable by just dividing both sides by 5. So when I divide by 5, that gives me that x is equal to 2. And so now I can solve for y by substituting my value for x into either of the two equations. So let's just start with the one with less numbers. Okay, so we've got this x plus 2y equals 3. And so we are going to substitute our 2 for x into that equation. Okay, so it doesn't matter which equation we choose. We could have chosen the other equation as well. Okay, so we're going to substitute into one equation. I'm going to shorten equation EQN. Okay, so now that we did that, we have 2 plus 2y equals 3. So now to solve for y, we want to subtract 2 from both sides. So 2y equals 1. And then if I divide both sides by 2, that tells me that y equals 1/2 for this system. And again, it was just asking me for the y value. So that's my answer. Okay, so this one was nice because I just had to add things together and something was eliminated. For other systems, sometimes that doesn't happen. So if I look at these, I have 3x plus 7y equals 15. And then I have 5x plus 2y equals -4. And so for those values, notice that I can't just add them together. I'm going to make my 2 look a little nicer. So what I do have to do is figure out a number that I can multiply one or more of the equations by in order to cancel. So one thing that I need is I need to have opposite signs and the same value. So right now I don't have either of those. So I know that one of them I'm going to have to multiply by a negative. So the best way to kind of do this is to just think about a variable. It doesn't matter which variable to eliminate. Let's just look at the x's. So if I wanted them to be the same number with opposite signs, I have to multiply them each by a number. So if I have 3 and 5, the number that I want to get is 15. So I can multiply this entire expression by 5, and that'll give me 15x and some other stuff. And then I can multiply the second one so that it cancels. So if I have 15x, I want a -15x. So I'm going to multiply the second equation by -3. Okay, then I'll be able to add these together. Okay, so let's simplify. So 5 times 3x is 15x. Actually, let's write this on the side so we can see it transparent. 15x, and then 5 times 7y, so plus 35y. And then 5 times 15 is 75. Then we want to multiply that -3 by 5x, which is going to give us our additive inverse. And then -3 times 2y is going to give us -6y. And then -3 times -4 is going to equal 12. Okay. So our second equation is now -15x minus 6y equals 12. Now that we have those additive inverses, we can add these two equations together. So -15x plus 15x was our whole point, was this is an additive inverse, that makes 0. So then 35 plus -6 is 29y. And then 75 plus 12 is 87. So now we have an equation just in y. And we can divide both sides by 29 to determine what value y is. So y equals 87 divided by 29, which is the number 3. Okay, so we had to multiply to get an additive inverse for one of the variables. That allowed us to solve for the other variable. What we want to do now is substitute y equals 3. Y equals 3 into one original equation. Okay, so it doesn't matter. I'm just going to pick the first one. So we're going to take the 3x plus 7y equals 15, and we're going to substitute 3 into the place for y in that original equation. So it's going to be 3x plus 7 times 3 equals 15. So if we simplify that, we've got 3x plus 21 is equal to 15. And so then if we subtract 21 from both sides, that gives us that 3x is equal to -6. And then dividing by 3 gives us that x equals -2. So what this means is that the solution to this system is -2, +3. So for the next one, it looks like we have to multiply by something as well in order to find our additive inverses. So if I just copy the system out, so I've got -3x plus 5y is equal to 7, and then +6x minus 10y is equal to -14. So let's just look at our x's again. For this one, I have -3 and 6. And so what's good about this is that they're already opposite signs, so I only have to multiply by a positive number. And I can get 6 by multiplying this first equation by a +2. So I'm actually going to just leave the second equation as it is, because 2 times -3x gives us -6x, which is the additive inverse of 6x. So then let's distribute the 2 all the way through. So that's going to give us plus 10y is equal to 14. So what we should be noticing now is that this equation looks a lot like the other equation, except all the signs are just the opposite, which means what's going to happen when we add them together? -6x plus 6x is 0. -10y plus 10y is 0. So this whole left side is 0. And then the right side, 14 plus -14, is also 0. So what happens when we get this kind of statement where it's just values instead of variables? What we're identifying is whether this is true or not. Okay, so this is a true statement. 0 is the same as 0. And so when we end up with a true statement, our answer is that there's infinitely many solutions. So when the variables eliminate, I end up with a true statement. I have infinitely many solutions. Okay, so let's look at one last problem to solve by elimination. And so we have negative 2x plus 4y equals 6. And then we have negative 3x plus 6y equals 8. So as we look at our first two terms, 2 and 3 are different. They're both the same sign too, so we're going to need to multiply by a negative for that. If we look at our y's, the same thing happens, right? 4 and 6, those are different numbers. I would have to multiply both of them to get a common value. So let's just look at the x's again because the numbers are smaller. So if I want these two to eliminate, the first number I can get is a 6, right? So I can get a 6 by multiplying the first equation by 3. Let's just do a negative 3 because we know we have to change one of the signs. Okay? So if I multiply this equation by a negative 3, that means I have to multiply the second equation by a positive 2 so that my first equation will have a positive 6x and my second equation will have a negative 6x so that I have two additive inverses. Okay, so let's distribute. So if I multiply negative 3 times negative 2x, I get positive 6x. If I multiply negative 3 times 4y, I get negative 12y. And then 3 times 6 gives me a negative 18. So my first equation has turned into positive 6x minus 12y equals negative 18. For the second equation, as I distribute the 2, I get a negative 6x. And then 2 times 6y is going to give me plus 12y. So we should notice something happening here that happened last time. And then 2 times 8 gives us a positive 16. So what's different now is that our equations didn't end up exactly the same, right? So in that one, we had the same exact numbers, but opposite signs. This one, we have all opposite signs, but notice these two numbers are different. And so when we go ahead and add these two things together, the left side is complete opposites, right? Negative 6 plus positive 6 is additive inverses, so that goes to 0. And then negative 12y and 12y are additive inverses, so that also is 0. But on this side, negative 18 plus 16 is negative 2. And so notice that this is a false statement. So those are not equal on both sides. And so when we have this, that's when we have no solution. So that's when, remember when we graphed, these lines are parallel lines. Whereas for this one, if I were to graph the two lines visually, I would have the exact same two lines, so they would overlap. Okay. So sometimes we have to multiply both equations by a number to eliminate. Sometimes we just have to multiply one equation by a number to eliminate. And we'll see all kinds of different answers in terms of ordered pairs, infinitely many, or no solutions. So the assignment for this is these 6 problems. Make sure you're doing this on notebook paper.